Configure shared storage for vSphere. All right, so we've got the networking piece up and running on our vSphere environment. Now we're going to start taking a look at some shared storage. Now, one of the reasons why I moved this shared storage piece to behind the networking piece is that a number of the different protocols that are in use today for connecting servers to their storage involve the use of Ethernet. And Ethernet obviously runs on a network and uses the whole TCP/IP protocol in order to be able to connect your servers in with your storage. Now, that's the case here in terms of iSCSI. It's also the case here in terms of fiber channel over Ethernet and even NFS storage. In the case of fiber channel, there is that whole sort of dark art that's associated with making fiber channel connections between server and storage. And we're not going to spend much time on fiber channel in this nugget. We want to focus in on these Ethernet-based protocols because they tend to be just a little bit more involved from the ESX layer. What we do want to do, however, in this nugget is help you understand that storage really, once it's been connected into an ESX server and then exposed into vCenter, really storage is just kind of considered to really be the same thing. Right? Whether it's iSCSI or fiber channel or FCOE, once the storage connection is done, well, then creating the data store and working with that data store, it all just operates as a piece of storage for an ESX host. I've split up the storage topic into two pieces, and this is the first of the two pieces here as far as creating those storage connections. The second piece is actually next in the next nugget, when we're talking about the whole data stores and what's involved in order to actually work and interact with your data stores. I break this up because those are really kind of the two halves of dealing with storage in vCenter. And in this nugget, we're actually going to first take a look at some of the storage naming conventions that are out there. And then in the click-by-click portion, what I want to do is help you understand how you will essentially make those storage connections. And I'm going to focus on iSCSI at this point, although the processes for fiber channel are similar enough that you can at least be aware of them. iSCSI involves a little bit more effort because as an Ethernet-based protocol, you've just got more Ethernet-based work to put together in order for you to make that connection occur. I also want to show you NFS connections and data stores in this nugget as well, because those NFS connections and data stores, a little bit different. The configuration just slightly different than iSCSI. NFS is actually kind of developing kind of a fan base from a lot of administrators. Originally, NFS was one of those protocols that you would use for storing only your ISO files and some of those tangential sort of artifacts that you would need to have inside of an NTF or inside of a vmfs data store. But some people are actually finding NFS connections with decent enough speed that for even some second tier and in some cases first tier VM requirements, perhaps even running virtual machines over NFS. So you need to understand what iSCSI is. You need to understand how to make those NFS connections. I do want to spend just a minute talking about what these vCenter server storage filters are, because they're there for the exam predominantly, but they're also there to help protect you against making some mistakes as you're configuring these storage connections. Before we get there, however, what I do want to spend is just some time just taking a look at the different storage naming conventions that are now available in version 5. Some of these are brought over from version 4, but from originally in ESX version 3, which used predominantly the vmHBA naming convention with the ACTN little lexicographical convention here that identifies the adapter, if there are more than one channel, if there are more than one targets associated with that, and then what LUN. That was how version 3 actually essentially identified what each piece of storage was. Now in 4 and then once again in 5, we now have these additional storage naming conventions that are out there. The NAA, or the Network Addressing Authority Identifier, is one. Also the EUI, or Extended Unique Identifier, is another way of uniquely identifying a particular piece of storage, and then also its partition here after this colon. These two are very long strings of letters and numbers, and they're designed essentially to uniquely identify a piece of storage that is presented as it's presented to the ESX host. Now this is somewhat different than the original vmHBA here with the MPX prefix on it. An MPX prefix is used whenever the storage does not, or the storage device does not provide the NAA number to ESX. So when that happens, an ESX server is actually going to generate its own tail end back here, its own suffix, to identify and uniquely identify what that LUN or disk is going to be. There's also this VML identifier down here. You can kind of use these interchangeably with the ones on top, and then every disk has a unique identifier or a UUID. But you kind of just want to be aware, again, for the exam, and also so that you're aware when you have to go about finding which disk or which LUN is associated with whatever it is you're trying to do whenever you're managing your vCenter environment. All of these storage naming conventions are exposed and are going to be available to you using the myriad of command line commands that are out there. In a minute, I'll also show you some places where you can find them inside of the GUI. But for now, and before we actually get into these storage filters, what I want to do is take a look at the vCenter server itself that we've been working with, and how we can actually really take a look at creating some initial connections here across this vSwitch that we created in the last nugget. Now, if you recall back on that last nugget, we created a second vSwitch, and we associated that with vmNIC1, and we created a VM kernel port that is intended to be used as our storage connection. And I'm showing you all of this because I want you to become familiar with the whole process of connecting in Ethernet-based protocols into ESX. We have already separated out the different adapters. We've already created the necessary VM kernel ports. And so really all of the effort that's required here in the networking properties has been completed as part of the last nugget. What we've got to do now is actually move not from the networking location, but actually over here into the storage location, here under storage adapters, so that we can then turn on the storage adapter and ultimately configure that storage adapter to use the networking connection that's already been set up. Now you'll notice here that we have a number of different storage adapters that are available by default. There are some block SCSI adapters here that are available by default. This is essentially the CD-ROM drive down here at the bottom that's been attached. And then we also have this SCSI here, this Ultra 320 SCSI, which is effectively the local disk. Now you'll see here's an MPX identifier for the vmHBA1, that first adapter that's been plugged in here. And as I said before, this is essentially that 40 gig disk on LUN 0 that we're using as the root for storing ESX's operating system files. Now, admittedly, there's not much that we can do here with this vmHBA1. What we're looking for at this point is to actually create an iSCSI connection to a piece of remote storage. Now, you probably are already aware of this, but for vMotion to work in version 5, we do have to have, well, a piece of shared storage whereby all of the different ESX hosts connect into that shared storage, and then all of the VMDK files, the individual files that are the virtual disk files for the virtual machines, all of those VMDK files will get hosted and stored on that piece of shared storage. We're going to connect to that via iSCSI. The first thing we need to do in order to enable that connection is to actually add a new storage adapter. And you can see here, if I click the Add button, I can add a software iSCSI adapter into my list of adapters. If I had a Fiber Channel over Ethernet adapter, this would be available for me as well, but what I'm looking for here is software iSCSI. When I add that adapter, it's going to add it to the storage adapters list. Then after it's been added into the storage adapters list, the next step in the process is just to actually click on that adapter and then view its properties. Now here inside of the properties screen, you can see a little bit of information about this iSCSI connection. I have my IQN number here, which is the name of my IQN adapter here, and then I also have the target discovery methods that are actually enabled for this adapter. And you can see here that the software initiator has been turned on. If I click the configure button here, I can actually enter in an iSCSI alias if I want, just to make things easier so I don't have to remember the entire iSCSI name, this whole IQN name that's been created for this adapter. Or I could go about actually removing iSCSI, the initiator, and turning it off if I wanted to. There are some advanced features here that I'm not going to go over, but there's an entire long list here of particularly advanced features that one assumes your storage device manufacturer may have you adjust. But unless they have specifically requested for you to make changes to this advanced settings screen, or if VMware has, you're generally not going to make many changes here into the advanced settings screen. Now, your security policy may want you to create some sense of security or authentication between the initiator here at the ESX side and the target over at the storage area network. Now, one of the ways that that can be accomplished is through the use of the Challenge Handshake Authentication Protocol, or CHAP. Now, CHAP is, admittedly, it's not the best authentication mechanism in the world, but it is the mechanism that iSCSI targets use to authenticate back and forth between the target and the initiator. Now, what CHAP uses is essentially a shared secret, meaning that you will need to enter in the name and the secret associated with the target and potentially with the host as well. Now you can see here that in traditional CHAP, the target actually authenticates the host. In mutual CHAP, you have essentially both. The target authenticates the host and the host authenticates the target. And you can turn on each one individually if you want. Now, you'll only turn these on if you have a security policy that determines that you need to have authentication either one way or bidirectional between target and host. This does not encrypt the traffic between target and host. It actually just goes about authenticating that initial communication so that you can ensure that the person who you think you're talking to is actually the person you are actually talking to in this iSCSI communication. Once you've set up the security pieces here with CHAP, the next step is to click over here under Network Configuration. Now, what this screen does is it provides a very nice location for actually setting up the VM kernel port bindings between which VM kernel adapter you want and which port group you want for the use of iSCSI. Now, if you recall, I created that virtual switch over there, vSwitch1, that's titled Storage, and it's associated with VM kernel adapter vmk1. We want to actually bind this to iSCSI here so that we can actually make use of that VM kernel adapter for the purposes of iSCSI. By doing so, you'll see the port group policy is set to compliance. I'm not using multiple paths here, so I don't have to worry about the path status. Although if I were using multiple paths, and which is generally a really good idea with iSCSI, you would see this here where you could actually verify that the path status was compliant or not. Now, once I have at least a single connection set up here in the Network Configuration tab, the next step is actually to go here under Dynamic Discovery to identify the servers, or the storage servers, the storage processors, that are going to be exposing iSCSI LUNs for the purposes of use by this ESX host. Now, I have actually installed a software-based solution. Starwind Software is the name of the solution. You can download it for free from Starwind Software. And it exposes an iSCSI LUN so that it can be picked up by a target, or by an initiator, I should say, to be used for the purposes of shared storage. That iSCSI LUN is currently available on the server 192.168.0.201. If I click the OK button here, you'll see that I'll actually locate that server over port 3260. And if this responds, then I know that I'm actually listening on this IP address and this port. If I absolutely have everything correctly identified over on the storage side, well, then I can click over here under Static Discovery and identify what specific target name has been exposed for use to this server. You'll see here's the IQN name for the Starwind software-based SAN I've created. It's vc.company.pri, and the name of the LUN is VM Data Store 1. Now, just like before, I can go through here to settings and set up some advanced settings, essentially adjust what their configuration is if it needs to be different from what the parent was there on the initiator itself. Or I can set the same thing here with CHAP settings, either inheriting them from the parent or overriding them here within this screen. I don't really want to do that at this point because what I want to do is essentially make this piece of storage available to this ESX host. Once it's done, I can click the Close button here and then rescan the host bus adapter, and that should actually pick up that little piece of storage that I've connected here. Looks like we have, here's iSCSI software adapter, and then I have a single connected target, a single device, and I'm connecting to it via a single path. So once I've confirmed that I have that path to the storage and that I've connected up appropriately, the next step here is to go up into the storage node and actually add the storage that I need to. Now, I'm not going to do that at this point because I want to save that for the next nugget when we start talking about data stores and how to work with data stores. What I do want to show you here is that this storage adapter here has that single device and single path, and I've already configured over here on ESX2 the iSCSI software adapter for also a single connected target, a single device, and a single path. So once we get into, in the next nugget, when we start talking about data stores, once we get into actually creating that data store should be exposed for use by both ESX1 and ESX2. Now, this is the process one would go through to actually connect up an iSCSI connection. But iSCSI is only one of the ways that you can connect storage into your ESX host. Yet another way is through an NFS connection, or a network file system. Now, NFS is most commonly associated with Unix or Linux, and so if you go to a Unix or a Linux operating system, you'll be able to create an NFS mount pretty much through the command line operating system. In order to use NFS here in the Windows operating system, you actually have to install some functionality in support of that. Now, that functionality is here as a Windows Server 2008 R2 feature. And, role up here on the top. And if I click and choose to add roles, and then next, and you'll see here the file services role. This file services role, beneath this file services role, are a number of different role services that you can actually install for the purposes of serving up files. And one of those role services that is available is the Services for Network File System role service. Now, I've already got this installed, so we don't have to watch the installation occur. There's really nothing to see as part of that installation. But one of the things that it does do is it does expose some additional tabs when I start to take a look through different folders that are available on an operating system with this installed. Now, I've created this NFS_mount folder in my F drive here, and inside of this NFS_mount folder, what I've done is actually added the Windows Server 2008 R2 SP1 ISO file. Remember, one of the uses for NFS, at least originally, was so that you could provide a place to add the necessary ISO files that you need to an available data store so that you could make use of them from within the vCenter server. If you don't have those files inside of a data store, then you won't actually be able to use them. Your operating systems, your virtual machines won't be able to use the files. Any sort of file that vCenter makes use of has to exist within a data store. Now, most of us have some sort of IT file server or file share existing somewhere in our network. You probably have some share located somewhere that includes all the ISO files for your operating systems and all the different applications you may install to those operating systems. With that file share, you could potentially do exactly what I've done here and install the services for Unix, essentially, and create a mount or expose this mount directly into vCenter server. Now, the way that you go about doing this, once you've installed the correct services, the correct role services, is to right-click on the folder that you're looking for and to choose Properties. Once you've chosen Properties, you'll see a new tab up here called NFS Sharing. NFS Sharing is very similar to the traditional sharing tab here, in that this is the location where you actually enable what sorts of permissions that you want to expose or add to that specific folder. The first thing you have to do is click the checkbox to actually share the folder and provide that share a name. Most of this you can actually leave the same, except for the permissions button down here at the bottom. Now, I'm actually operating as root on that server, and so what I want to do is enable the type of access here to change from read-only to read-write, and then also to allow root access so that root can make use of this file share once I create it as an NFS mount. Once I do that, I now will be able to use this folder as an NFS mount and connect to it from within ESX. Let's go ahead and do that here back under the vSphere client. Now, you'll see I'm back here under storage adapters. What I want to do is go up to my ESX1 host here and click under Storage, and then click the Add Storage button. Now, you'll notice here I have disk/LUN, and this is for creating a typical data store on top of Fiber Channel, iSCSI, or to mount an existing VMFS device. But what I really want to do here at this point is to create a connection to a network file system mount, or network file system share. If I click the button here and choose Next, you'll see that I have another dialog box that appears that asks me for the server where that mount is located. In this case, it's 192.168.0.201, and the folder name is NFS_mount. I'm going to give this a data store name also. I'll call it NFS mount, and then click the Next button. Finally, I'll click the Finish button here, and after a second or two, you'll see that this NFS mount data store actually gets created. This data store is connected to 192.168.0.201. It's the NFS_mount device here, as you can see. It is a 256 gig capacity with 51 gigs free of type NFS. I have a little bit of a warning here on this. If I click down here under alarms, I'll find out that that warning is just related to the data store usage on disk, so I'm coming close to being out of space. What I really want to do here is not necessarily take a look at the characteristics of this data store, but to actually dig into this data store to take a look at it. And as you can see here, in the root of this data store is indeed that ISO file that I added inside of Windows. Had this have been my NT file share, and had it have had all of the different ISO files that I've created and collected over the years, well, all of these would now be exposed and available to my ESX host so that I could make use of them inside of all the virtual machines that I have. Now at this point, we've actually gone through the process of dealing with both the iSCSI side and the NFS side of creating these necessary storage connections. There's one very minor topic here that's probably not necessary for you for building your environment, but is if you plan on taking that exam, and that's the whole concept of storage filters down here at the bottom. Now these storage filters are available for you by default, and they are enabled by default. They are designed essentially to protect you against certain types of storage configurations getting set up that don't actually make sense for ESX. So I have a VMFS filter here, I have an RDM filter here, I have a same hosts and transports filter, and also a host rescan filter. By having these turned on, these will actually make certain types of storage not available to you inside of the interface to protect you from accidentally connecting them in inappropriate ways. If you did, however, want to disable these storage filters, you could take any one of these configurations here, config.vpxd.filter.vmfs filter, and actually apply those to your ESX host. Now where do you do that? The place where you do that here is under Administration, vCenter Server Settings. And if you click down here under Advanced Settings, you'll see a number of different advanced settings here that have been set up. You should also notice that none of the storage filters that we just looked at actually exist here in this list. So that the only way to actually disable these storage filters is to enter their information in manually into this location and supply them with the value of false. They are already set to true by default, but setting them to false will actually disable them so that you will be able to see more exposure to the different storage types that you have. Now, as I mentioned, these are put into place to protect you against creating configurations that are inappropriate for the server. So you're probably only going to do this if you're told specifically to do this by, for example, VMware, or if your storage vendor has asked you to disable these for a particular reason. So what have we talked about in this nugget? We've talked about how to configure shared storage for vSphere. And we talked about all the different types of use cases for storage, iSCSI, fiber channel over Ethernet, and NFS. And we focused specifically on both iSCSI and NFS so that we could take a look at how Ethernet-based connections are actually set up inside of ESX, and specifically vCenter Server. We talked about those storage naming conventions as well, and how you need to be aware of those because you're going to get those thrown at you at during different types of situations as you're working with your ESX hosts. And then we went through and went to create some iSCSI connections, associate them with CHAP authentication, as well as some NFS connections and data stores, and ultimately how to create those storage filters to disable them if you find you don't want them turned on. I hope this has been informative for you, and I'd like to thank you for viewing.